I'm skipping the official intro to this topic, and I'm going to go straight to an example. I think you're going to get it. And then tomorrow I will do the actual official reason why this is, okay? Okay, so there are 3 green, 2 red, and 4 blue marbles in a bag, right? So we've got, right off the top, we've got 9 total. You are drawing 2 of them in a row. That is important here. Determine the probability, and I want the answer with and without replacement. That is another thing I want you to highlight. So we're going to take this page and find the midway point. I think it's right under the Y here, and try to split it in half. And the left side is going to be replacement. Like you're replacing the marble. Once you take it out, you're like, oh, it's a red one. Cool, let's record that. Let's put it back. The next one on the right side is without replacement. You're taking one out, and then you're taking another one out. And so let's see how the probabilities will be different. It says here, what's the probability of picking a green and a red marble? So we'll go probability of green and red is simply going to be probability of green times probability of red. What is the probability of getting a green one? 3 out of 9, correct? And the probability of getting a red one is 2 out of, is it still 9? I've replaced the first one. I'll put it back. So we're still back to 9. What do you do when you multiply fractions again? You multiply numerators, you multiply denominators, right? So 3 times 2 is 6. 9 times 9 is 81. Let's just leave it like that for now. I will just give it as a decimal here, so you see 0.0741. That's the probability of getting a green and then a red one. One after the other. What if it's probability of, in this case, green and red? It's going to be probability of getting a green one, and I'm not replacing the first one, right? It says without replacing. So this is weird notation here. Are you ready for this? You will then note to everybody that's reading this thing right here will be like probability of getting a red one given that a green one has been taken out of the bag. I will say more on that tomorrow. Don't focus on the notation too much today. What's the probability of getting a green one from the very beginning? 3 greens out of 9 total, right? What's the probability of getting a red one given the fact that you took out a green one and you haven't replaced it? How is that going to change your total? You're going to go down to 8. And has the green one that has been removed, is that going to affect the number of reds you have on your second? No. So you just go 2 reds, nothing changes. 3 times 2 is 6. 9 times 8 is 72. I'm not going to reduce it. I'm just going to show you that the probability changes when you don't replace. Okay? When you don't replace, something changes, and I think you can see it. You can see it. Oh, the total went down. Yeah, there's definitely a dependent situation. Okay? Hold on. 2 blue marbles. Let's just do this one. I want you to finish this page at home. 2 blue. We are still out of 9, right? We've got 4 out of 9. And we still have 4 out of 9 for that second one because we replaced the first one. 4 times 4 is 16. 9 times 9 is 81. Over on this side, however, we're going to draw the first one, 4 out of 9. And I want you to pay attention to this one. Is my total going to be affected if I don't replace the first one I take out? It's definitely going to be affected, right? I'm down to 8. Is the number of blue marbles, because remember, I want a blue one and another blue one. Is the number of blue marbles affected as well? Because I took a blue one out, right? So then it's 3. So this is a case where both are affected by the first one. 4 times 3 is 12. 9 times 8 is 72. I'm just going to leave it at that. Total affected. And blue ones affected. Blues affected. So in this case, both the top and the bottom has been affected because you're doing the same color back to back. Okay? When something is being removed, listen carefully before the bell goes. When something is being removed and not replaced, this is what you have to watch out for. And it's called dependent probability. They're dependent on each other. We'll do more on that tomorrow. Can you do 39 and 40, guys? I'm just going to leave it at 39 and 40. I'm not asking for too much, I don't think. So homework, 39 and 40. Ouch. There you go.